The CEO of Anthropic recently predicted that half of all entry-level jobs will disappear, with unemployment potentially hitting 20%. This displacement is driven by a specific technological shift, the rise of AI agents. We saw similar anxieties in the 1970s with the introduction of the automated teller machine. At the time, the industry expected early ATMs to entirely replace human staff. Instead, the number of bank tellers increased over the following decades. Their responsibilities moved away from mechanical cash counting towards coordination, judgment, and high-level customer service. Standard enterprise automation follows a rigid path. Like a vending machine, an unexpected error stops the process entirely. Agentic AI, however, operates through a probabilistic loop. It perceives its environment, reasons, acts, and evaluates. If it fails, the agent iterates until successful. While building a single agent is a straightforward technical task, the challenge for modern enterprises is scaling these systems reliably without triggering massive operational or compliance failures. Managing this complexity at an organizational level involves a shift in architecture, moving away from monolithic models towards distributed multi-agent systems. The foundational unit of this architecture is the single agent node. It is governed by three constraints. First, action defines its specialized role. Second, reasoning programs the logic boundaries it must solve. Finally, memory determines the exact data it can access. If boundaries are undefined, the model attempts to match any available pattern to satisfy a prompt. This leads to hallucinations, where the system produces confident but entirely inaccurate outputs. To prevent this, the reasoning sector must be anchored to specific verifiable facts, a process known as data grounding. Mathematically, an agent with poor data grounding or loose constraints will prioritize delivering a fast output over a correct one. Effective grounding requires three distinct streams. First is secondary data, external information like market trends. Next is historical data, connecting the agent to internal enterprise records. Finally, the system integrates primary data, live inputs like active test results or user surveys. When Kotak Mahindra Bank utilized this tri-layer structure, a single agent turned a 4-word prompt into a complete, compliant marketing campaign in under 5 minutes. By reasoning through the historical and market data, the agent automatically segmented the audience and generated distinct, personalized creative assets for each group. This grounding ensures the agent's logic remains tethered to the actual mechanics of the business, rather than the generic data it was originally trained on. It is tempting to try and build a super agent, one massive model that holds all company data and manages every operational role simultaneously. However, forcing a single model to manage conflicting goals, like maximizing customer engagement while strictly enforcing legal compliance, causes critical logic breakdowns. Research into the mechanics of large language models reveals a specific failure point known as the lost in the middle problem. Researchers found that as a prompt grows, a model's ability to retrieve information follows a U-shaped curve. Information at the very beginning or end of the context window is recalled accurately, but instructions located in the middle are frequently ignored. In an enterprise setting, this context window overload creates significant operational risks. A generalized support agent may process thousands of lines of documentation and fail to distinguish between a minor UI suggestion and a critical system outage, simply because the outage protocol was buried in the middle of its context. Forcing an AI agent to handle massive scope doesn't increase intelligence, it decreases safety and reliability. The architectural solution is to break the monolithic model into specialized sub-agents, each with highly restricted parameters. This network is managed by an orchestrator node, which coordinates handoffs and quality control between the various specialists. In a content workflow, one sub-agent is dedicated exclusively to scouting, scanning market data for viable topics. The orchestrator evaluates those topics against brand guidelines before routing the data to the next stage. A writer sub-agent generates the draft, with memory restricted to creative history to ensure correct tone. Finally, a compliance sub-agent audits the draft, checking the output against strict regulatory parameters. This same structure applies to complex customer support systems. By setting strict decision rules for ticket prioritization, And using API connectors for tools like Zoho or Jira, the agents can execute real-world tasks without logic cross-contamination. Scalable AI execution is only possible when you aggressively narrow the scope of each agent and use central orchestration to manage the workflow. The core rule of this architecture is that precision and reliability scale inversely with the breadth of an agent's assigned scope. As these multi-agent systems become the standard, the primary impact will be on the structure of human organizations. Traditional businesses rely on two massive layers of human capital: execution and coordination. Multi-agent systems absorb both of these tiers. This shift pushes human roles upward. Employees spend less time on repetitive tasks, focusing more on high-level strategy and system design. The role of the subject matter expert is evolving. Instead of executing workflows manually, their primary duty will be defining governance constraints and auditing the outputs of autonomous systems. The enterprise leaders of the future won't manage individual tasks. They will architect the distributed systems that execute them.